Today, we'll be solving LeetCode 1926, nearest exit from entrance in maze. We start by getting the number of rows and the number of columns in the maze. This will help us check boundaries later. Next, we create a queue data structure, which we can get from the collections library. The queue will hold the cells we need to explore. Each element in the queue will store the row, the column, and the number of steps it took to reach that cell. We begin by placing the entrance into the queue with 0 steps. We also mark the entrance as visited by turning that cell into a plus sign. This prevents us from revisiting it. Now we set up a while loop that runs as long as the queue is not empty. This loop will process one cell at a time. Inside the loop, we remove the first element from the queue. This gives us the current row, the current column, and the number of steps taken so far. Then, we explore the 4 possible directions from this cell. To do this, we create a list of direction offsets, 1 step up, 1 step down, 1 step left, and 1 step right. For each direction, we calculate the new row and new column. We need to check whether this new position is valid. That means it must stay within the maze boundaries, and it must be an empty cell, not a wall. If it is not valid, we skip it. If the new cell is valid, we next check whether it is an exit. A cell is an exit if it is on the border of the maze, meaning the row is 0, or the row is the last row, or the column is 0, or the column is the last column. If it is on the border, and it is not the entrance, then we found the nearest exit. In that case, we immediately return the current step count plus 1, because moving into this new cell adds 1 step. If it is not an exit, we add it into the queue with the updated step count, and we also mark it as visited by changing the maze cell into a plus sign. That way, we do not process the same cell again. If the loop finishes and we never return, that means there is no path to any exit. In that case, we return -1.